Welcome to Standardizing with Z-scores. This is a very popular concept in any statistics course that you run into, and also just a very interesting concept that I've used even in my own life when I'm trying to make some comparisons. Because let's face it, most of the things that we deal with in real life, we can't really compare because let's face it, they're apples and oranges. So really I'm going to show you how Z-scores can help us make comparisons when things are like apples and oranges. For example, let's say I have oranges, I bought some. And they told me that the average orange is somewhere around 3 pounds. Now you might be thinking, well, that's a massive orange. Maybe it's a grapefruit. It's possible. I'm just trying to demonstrate the idea behind this. Let's say give or take 0.5 pounds. Again, that'll still be in pounds. And then I have an apple, so we'll use a different letter because it's going to weigh, let's say 1 pound. Much lower, but it's going to weigh less, and let's do 0.3 pounds, give or take. Not too bad. So let's say I go to the grocery store, la 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 la, I find an apple, and the apple I found, weighs, let's say, 2 pounds. Let's say I do the same thing, I find an orange, and let's say the orange weighs 4 pounds. So here's kind of an interesting idea that most people will do when they come across. They're like, oh, they each weigh 1 pound over. But here's the problem. Apples to oranges, they have very different standard deviations. So now the question becomes, well, which one is more unusual? Did I find one that's severely overweight? And if I did, how odd and peculiar is that actually, how peculiar it actually is? So that gets to be the really fun part. So here's the thing, because standard deviations show how much a group varies, it tends to be this natural ruler, so to speak, when it comes to comparing things, how unusual that one apple is to its entire group, and if so, is it more unusual than the orange? So in a previous video, I talked about snowfall, and I said there's an average of 9 inches, give or take 2 inches, and we built this normal model. And it's not too bad. And we broke it down in percentiles, because again, here's the average, which should be around the 50s. And then again, here's 9 inches, and I went up 1 standard deviation. So I up 1 to 11. I went down 1 standard deviation. Notice 1 standard deviation, down 1 standard deviation. Again, there's 2 inches, so here's the +2, and then there's the -2. Notice I put a little z next to it in the previous video. Those are what z-scores are. It's the number of standard deviations a data point is away from the mean. So when it comes to calculating these, I highly recommend you pause the video and try to see if you can come up with some kind of formula that takes, okay, if I wanted to know how far away in standard deviations 11 was from the average, which is 9, how could I figure out a formula that gets me the number 1? Please pause the video and try this on your own. Make some predictions. Hi, welcome back. So I want to go ahead and kind of help you out. So again, it does talk about how far away a data point is, which tends to talk about, distance perhaps. That shouldn't be a foreign concept in any math class, is measuring distance. And normally when I know how far away it is, I do a little subtracting, like 11 minus 9. Okay, notice the standard deviation, I had that at the very top, was 2 inches. Well, I want to know in how many standard deviations? Split that by 2, which is the standard deviation. Oh, look at that. I get down to 1. Let's try the same formula with 13. Okay, 13, how far away is that from the mean? Well, that's 9. How many standard deviations is that? Well, this number is 4. Okay, and I know the standard deviation is 2. Oh, look at that. It's 2 standard deviations away. Congratulations, that's the formula for z-scores. You take your individual statistic, let's say 13 days, and you subtract it by the average or the parameter, what you expect to be true, and then divide it by the standard deviation. This is the formula you will see on any AP statistics formula chart if you were in that course. Another popular way of doing it though is this, the individual, how far away it is from the average, and divide by the number of standard deviations. Not too bad. Please pause the video and jot that formula down. All right, so one thing I do want to point out when we do standardize, let's say I found somebody, I measured some snowfall, because we're still dealing in snow, and I found, wow, I found 12 inches of snow. I want to know how far away that is from the mean in standard deviations. So let's use that previous formula. Average, 9 inches. That's how far away it is from the mean. And I'm going to divide it by 2 to figure out how many standard deviations away it is from the mean. All right, I'm going to keep going on here. Let's see, I get the number 3, and I get inches on top, and I get the number 2 on the bottom. Oh, interesting thing right here are the units. Notice you have inches on top, and you have inches on bottom. So here's the problem. When you standardize, the units completely go away, and you're left with just this number. And again, this is in standard deviations. So if I find a snowy day that happens to give me 12 inches of snow, I can say that 12 inches is 1.5 standard deviations above average. And that's how you interpret them, which again doesn't make a lot of sense. So let's try it with some context. Let's take a look at Emma and Molly, who recently took a test in their class. So we have Molly, sweet Molly, made an 85 on her test. And then we have down here sweet Emma, she made a 78. Ooh, that already seems like Molly way outperformed Emma. However, let's take into account their classes because Molly is in first period, and first period had an average of 82 on the test, give or take 2 points. Whereas Molly is in second period, her class averaged 70, and her deviation was 5 points in that class. So now I want to say, well, who did better according to their classes when I take their class period into account? So let's do a standard score. So I'll do ZM for Molly. I'll keep her in green. Molly scored 85 on hers. Notice her class had an average of 82. So how far away Molly is from the mean, and then divided by 2 to figure out how many standard deviations away Molly actually is. And we're going to get 1.5. Well, it's not too bad. She's 1.5 standard deviations above average. Let's do the same thing, but let's do this one for Emma. Please pause the video and you calculate the standard score for Emma. Hi, welcome back. So hopefully when you found the deviation for Emma, again, Emma made a 78. It looks like she did worse, but her class average was a 70, and she had a deviation of 5 points. If you used your calculator, you probably got a z-score of 1.6. What? Mind blown. So here's the thing. Who actually did better? Emma did. Emma did better according to her respective class because she got a higher score. She got 1.6 standard deviations above average. So here's the interesting thing. What does that mean? If I tell you that you are 1.6 standard deviations above average, should you be impressed with yourself? Should you go, wow, I'm awesome? Or should you go, oh, that's interesting. Is what? Cool, question mark. So let's try to take these z-scores and put it into something palpable. So let's find out what percent of Molly's class scored below her. And again, Molly made an 85. So what are the chances, or what's the percent that anybody, so I'm going to use X because it could be anybody in the class, scored below her? And again, Molly made an 85. Because that should help us decide, is Molly's score amazing or is it just a little interesting? And again, we already calculated a z-score. So here's the thing. All of these are on a normal curve. And your calculator has a great way of finding percents if you have a given z-score. Because here's the problem. This is really the same thing as this question. I'll keep this in green. Her z-score is below, and again, 85, we just found that up here, 1.5. Because here's the thing, we had that cute little normal model we started off with, but notice 1.5 isn't on here. It's about right here. I don't have a percentile for that. I need to figure that out. So, to the calculator. I have an 84 plus for free if you have a different one. There's also plenty of websites online that are very helpful for finding this as well. But if you have the calculator that I have, you can hit second and var. So notice you see distribution, easy way to help you remember it. And you are going to calculate normal CDF. You're going to accumulate. And then notice I have some stuff in here from a previous example. What you probably have in your calculator is -1e to the 99, basically negative infinity. Negative, very, very, very small. And we're going to go all the way up to 1.5 because I want to go up, kind of matches that. Standard curve has 0 as a mean, deviation of 1. And all you need to do is hit the paste. And then paste one more time. Ta-da! There is your proportion or your percent. So it does ask percent, so I do need to make sure I answer that question. So 93.32. So what percent of Molly's class scored below her? 93, which means Molly is somewhere in the 93rd percentile. That's pretty good. So let's turn it around on its head. Pause the video and you try to answer part C. What percent of Emma's class scored above her? Hi, welcome back. Hopefully you wrote a sentence similar. Again, anybody in Emma's class, you can use X or another variable if you'd like. I tend to keep X because it keeps it simple. And again, Emma scored a 78. Not too bad. And again, we already know Emma's Z-score. We had that right up there. So probability, I'm just going to steal my answer from above, scored above 1.6. And again, you're going to use those same calculator steps, second vars, and you should get this. Notice I have the previous answer right here, and then here's the one that we're wanting. So, and again, what percent? So 5.48% of people scored above her. So again, Emma's somewhere in the 95th percentile, which hopefully supports what we got in A. In fact, Emma did do better. She performed much higher. All right, so we did an example. Let's try to kind of keep it basic. So just trying to understand how to go from a Z-score to get to a percentile. Please pause the video and try to answer A on your own using your calculator just for extra practice. Hi, welcome back. So I wanted to be sure I got a chance to show you. Notice this one says below a quarter. So again, second, then vars, normal CDF, all the way up to 0.25. Again, this is very helpful because that empirical rule, that 68, 95, 99.7 doesn't help us when we have funky Z-scores. So I have to be able to do something like this. Ta-da! There you go. Much easier. So, and notice this just says find the percent. So again, answering that question. So 59.87. So almost 60%, maybe a little less. Not too bad. Pause the video and try to do these on your own. This is B and C. Hopefully B looks a little familiar. You should probably predict what the answer is to be. Hi, welcome back. So notice this is asking what is the chances that I'm above and below one standard deviation? Well, hopefully that kind of brings it back to what we talked about in one of my previous videos or what you've already seen in your statistics course. The empirical rule, the 68, 95, 99.7. So notice below and above one standard deviation should be 68%. Hopefully when you put that in your calculator, you found that exact answer. So it should have looked something kind of like that. Notice you can put an upper and a lower value, and notice 68. So pretty close. Same thing here. You just want to make sure that the lower is 1.85. And then the upper is the one that goes to infinity. And again, pretty small number. And notice that Z-score is not that big. So let's try one last example. Let's do with a Keurig, a popular coffee machine dispenses tea, coffee, etc. A large mug dispenses on average 9.25 ounces, give or take 0.5 ounces. Assume a normal model is appropriate. That's always important. Please pause the video and try to answer part A on your own. Hi, welcome back. So it wants to know what are the chances that whatever I get gives me less than 9 ounces. Well, I need to standardize that. So I'm going to show you one other way of notating this. Some people like to do the Z-scores on the side. They kind of like to do them down here, equals, and they do all of that. A popular way that I've seen it also is they actually put it in the parentheses, less than, and they do their formula work up here. So I have 9 ounces. And then I have the average, so how far away it is from the average in standard deviations, 0.5. Not too bad. And again, we can do this in our calculator. I do want to show you one nice thing about these calculators. They do understand fractions. So if you hit alpha, y equals, notice option number 1 gives you that fraction. So 9 minus 9.25, 0.5. All right, there's my z-score, so negative 0.05. So now I can go into my calculator, second vars, normal CDF. Notice my upper needs to be negative 0.5. Notice it's negative because 9 is below average. And paste. Enter one more time. And there you go. Make this a little smaller so it can fit. Not too bad. So again, here's your z-score. And what is the probability? So probability, you can answer as a percent. So if you want to keep it as 30.85%, you may. Or if you'd like, you can leave it as 0.3085. Either answer is acceptable when it says what is the probability. One last thing I do want to show you is on a multiple choice question. You don't actually have to standardize if you don't want to. You can do second vars. So here's the thing. My upper was 9 ounces. The average was 9.25 ounces, give or take 0.5 ounces. So notice all of these are in ounces. Nothing is standardized. Paste, and then voila. Hopefully you see a familiar answer. Notice you get the exact same one, 0.38, 0.38. Not too bad. So this one down here is helpful for multiple choice. And then the one up here is helpful for free response questions, where you must convert to a z-score. You must standardize. It's very, very helpful. All right, pause the video and try B and C on your own. Hi, and welcome back. Hopefully you saw it's between two different numbers. So that's going to change how your answers work. So anything, what are the chances I go between 9 and 10? Hopefully you realized you should have had 2 z-scores for this question. You needed a z-score for the 9 ounces, 9 minus, and you needed another z-score for the 10. Yes, that will be counted, so you must show the work for both. And again, 9.25, 0.5 down for this one, same thing, 9.25, 0.5. And again, you can show the work below if you'd like. Just make sure when you put it up here, here's the first one, Z, there's where the second one will go. And again, punch it in your calculator. I'm going to kind of move some stuff around so you can see what I'm doing here. Oops, sorry about that. It's a little hard to move some stuff around. There you go. Okay, so hopefully you can kind of see that work a little bit. So again, here's that z-score. So for 10 is 1.5. Notice the 9 ounces, we already did that one above. So if this is a free response question, no, you don't need to perform the calculation again. So since we already did 9 up here, you can just put that right down there. And then notice that's exactly what happened on here. So here's the lower, here's the upper. So the chances that I get between 9 and 10 ounces is 62% or 0.62. On C, it wants to know there is a danger of overpouring because I want to know what happens if I get above 11 ounces. That's a standard large mug. So again, what are the chances that whatever amount I get, I've overpoured, which is above 11 ounces? Again, hopefully you calculated another z-score for 11. If you did, you should have got 3.5, which should have been interesting. Please make sure when you answered, you didn't put 2.36% or 0.236 because there is an E. Sometimes these probabilities are so small. The chances of seeing them are slim to none. And again, 9.25 over 0.5 if you needed to see that calculation. Please be sure you're careful how you do that. So you can either do 0.0023% or you can it in scientific notation. Please try part D on your own as well. Again, pause the video. I highly recommend you try these on your own. All right, customer calls and complains that her machine is only giving her 7 ounces when she ordered a large. Something tells me she's going to want her money back. Keurig, you horrible people. But the company has many statisticians on their roster, so they're like, hey, this woman is telling us that she's only getting 7 ounces. What are the chances that that's actually happening? Or really, is she lying? Should we be concerned? Because they're wanting to know any amount I'm getting, basically 7 ounces or less. What an interesting question. Again, make sure that you convert to a z-score. And again, I'll show you that other notation if you liked that a little better. So 7 minus 9.25 over 0.5. Here's the interesting thing. If you do plug that in your calculator, you probably got a very, very small z-score. I believe that z-score, again, should be negative because it's below average. Should be negative 4.5. Here's the thing. You just solved a problem up here where the z-score was 3.5. Look how small that number was. So really, you should accept and find a number even smaller. And again, here's all that work if you need to see that pointed out. Notice again how small. So should the company be concerned that the woman is telling the truth? I would say absolutely, because the chances that their machine is doing that is slim, if not to none. So very fun questions that you can answer using z-scores and using a simple calculator.